Now look at this series. We want to test for the divergent and the convergent of this series. So I'm going to use the root test to test for the divergent or the convergent of this series, whether this series converges or diverges. Now conditions: if this series is less than 1, the condition says it what? It converge. So if this series is greater than 1, so it what? It diverge. But if this series is equal to 1, we say the root test fails because we are using root test to test for this series. Alright, so what we are going to do from the basic rules of the root test, we see that the limit as n tends to infinity, we have the square root of n, or the nth root of the absolute value of an, right? So we are going to use this to test for the convergent or divergent of this series, where this an is this series. Alright, so this implies that the limit as n tends to infinity, we are going to replace this with this series, right? Because an is equal to this series, right? So this now becomes the nth root of this absolute value of minus 2n divided by n plus 1, or to the power of 5n absolute. Okay, now remember, when I clear this absolute, this minus sign will go, right? So we are going to have the limit as n tends to infinity. Clear this, remove this absolute, then the minus sign will go. So we are going to have the nth root of 2, sorry, it's not minus 2 again, is 2n divided by n plus 1 to the power of 5n. Alright, so this n root will form a power of 1 over n from the law of indices, right? So this now gives rise to, this implies that the limit as n tends to infinity, we have 2n divided by n plus 1 to the power of 5n. Now this is 1 over n if you want to raise it to the power, right? So if 1 over n multiplied by 5n, you're going to have 5n over n. Okay, why this n cancel out this n? Now we are left with the limit as n tends to infinity, we have 2n over n plus 1 to the power of 5. Now this